Okay, folks, we are back, and this is chapter 1-3. This is recording number 2. All right, I just did the system, or excuse me, the random sample method. Now, obviously, this is a very old-fashioned way of doing it using that table, but it's kind of helpful to kind of get an idea of how it works. But in real life, of course, everything is computerized nowadays. Okay, so we got the systematic sample now. Now the language here might be a little hard for you to understand. Let's see if we can take it apart here. Okay, so a systematic sample. Okay, this is a systematic sample. Is a sample, you obtain it by selecting every kth member of a population. Well, what do we mean by K? K is a counting number. So what the heck does this mean? What this is saying is you pick every kth person, every kth iPhone, whatever it is that you're trying to sample from. And K is a counting number. So K could be 1, 2, 3, 4, 5, and so forth. Okay, so let's take a look at the example here. You number each subject of the population, and then you select every kth subject. So where this is used all the time is in quality control in factories. They have like let's say you're making iPhones. The iPhones come down the assembly line, and you pick out every 100th phone and you test that phone. K would be 100. You pick out every 100th phone, every kth subject, every kth example. Okay, so his example, there's 2,000 subjects in the population. You pick out 50. You want 50. So how many? Every 40th one. So at K is 40. So every 40th subject would be selected. Okay. Then the first one is picked at random. Okay. All right. So I'll let you read that, but that's the concept there. It's a very simple concept, I believe. Okay. All right. Stratified sampling. Okay. So a stratified sample is obtained by dividing the population into subgroups, otherwise known as strata or strata. I'm not sure how to pronounce that. Have you ever heard that word before? Stratum. Stratum. A stratum is like basically a layer. Let's see if we can get a good definition of that. Okay, so what I just did was I opened up another window here. I like Google personally, so I went to my operating system is Chrome, Google Chrome. So I just go up here to the search bar and I type in the word define. If you put in the word define, it'll just give you a definition. It won't give you all of the other stuff that you would normally get. So define stratum or stratum. Okay, then we come up right here. Here it is. Let's see how you pronounce it.
Stratum.
Stratum. Okay. All right. So it's a layer or series of layers of rocks in the ground. Or that's for geology. For other contexts, it's a level or class to which people are assigned according to their social status, education, or income. So it's members of a social strata or strata. I'm not sure how you say it. What did I just say here? Oops. Oh, nuts. I didn't mean to do that. Let's forget about this. Okay, so it's a layer, okay, classification. Okay, so you divide the population. Now it's the population you're dividing. Every word counts here, right? You divide the population into these subgroups, and it's some characteristic that's relevant to the study. Okay, so let's see if we can parse this out a little bit here, and there can be several subgroups, of course. Okay, and then after you do that, then you select your subjects randomly from each of those subgroups. So you go back up to the previous way of doing things. Out of each of those subgroups, you select them at random. Okay, all right. So for example, you have a 2-year college. He wants to learn how students feel about a certain issue. He wants to know, are the first-year students different from the second-year students? You randomly select students from each subgroup to use in the example. I don't like that example. Let's use high school. I think it's a little easier to deal with. High school, you have 9th graders, 10th graders, 11th graders, and 12th graders. Okay, so you want to know something about how they feel about things. So you divide them up into the 9th, 10th, 11th, and 12th grades, and that's the entire population. The entire population is is in the subgroup, and then out of each of those groups, you pick, let's say, 100 kids randomly, and then you say, okay, that's my sample. Now, there's all kinds of nuances here, right? Because depending upon what you're interested in, you wouldn't expect ninth graders to have the same attitudes as 12th graders, right? You wouldn't expect ninth graders to have the same attitude towards a career choice as a 12th grader, right? I mean, that doesn't even make any sense. So you have to be cautious in all of these things. Okay, cluster sampling. You divide the population into sections or clusters, and then you take one or more of those clusters at random, and then all of the members of that cluster are the members of the sample. Wow, that's completely different, right? That's a whole different concept. We're not picking people at random, you're taking the entire cluster. Okay, so you see the distinction there, right? Okay, you're dividing the entire population into clusters or groups somehow, some way, geographical area, like north, south, east, west, all right, or by zip code, or something, all right, somehow, some way you decide to do that. Then obviously you got to have a lot of clusters for this to make any sense. But then the researcher selects some of these clusters, okay? And then you use all of the members of those selected clusters as a subject of your samples, okay? So let's say you have a large city. There's 10 apartment buildings in the city. You take 2 of the buildings from the 10 and you interview every single resident of the building. Okay, now can you see the pitfalls of that? There's obviously going to be problems with that, right? Because of those 10 buildings, maybe it's a really economically I'm sorry, economically segregated type of a city. Maybe the north end of the city is where all the rich folks live. The south end of the city is where all the poor folks live. And maybe there's only 1 or 2 apartments on the east side and on the west side because that's mainly industrial. Do you see where you can have all these problems? So just picking specific buildings would not be diverse at all, would not be random. So it's a lot of problems with this sort of a technique. But again, this is a very, very complex subject matter. So we're just giving you an overview here. Okay, all right. Another example might be a study involving the patients in the hospitals. In New York City, how many hospitals have they got? I have no idea. Maybe they have, I don't know, a city like New York, maybe they have 50. So instead of trying to look at all 50 of those hospitals and picking, random people out of each of those hospitals, can you imagine the nightmare of going from one hospital to the next out of 50 hospitals? It's much easier to just pick 2 or 3 of these hospitals and then talk to everybody in that hospital. So these are the sorts of things that the researcher has to consider when he's trying to come up with his study and trying to figure out how is he going to do this. There's the perfect way of doing it. In a perfect world, you do it a certain way, but then there's a practical way of doing it. You don't have infinite resources. You don't have infinite time. So you have to make some compromises. Okay, so here's some cartoons that will help you understand all this stuff. I'm going to leave it to you to look at. I think it's reasonably clear. Okay. All right. The cluster is the one that's always kind of confusing to me. You got all these zip codes here, or area codes. You have these area codes. So instead of trying to pick 5 or 6 people from each of these area codes, you pick 2 area codes. You pick 814, which is right there, and you pick 717. You pick this one, and you pick this one, and you look at everybody inside that area code. Okay, so here's the main difference. The main difference between stratified sampling and cluster sampling. Okay, the main difference is that in both of these, that you're dividing the population into groups. Okay, but the subjects in the groups for stratified sampling are more or less homogeneous. Okay, they have similar characteristics. That's how you pick the stratum. That's how you decide how you're going to divide them. Okay, so like all the 8th graders, all the 9th graders, all the 10th graders are all in the same stratum. Okay, they're in the same stratum. Okay, they're more or less homogeneous. Homogeneous means basically the same, right? They have similar characteristics. Whereas in the clusters, you kind of make the assumption that they're little miniature populations, that they vary in characteristics the same way that the larger population does. Okay, so that's kind of the big difference there. Okay, all right, I'll let you read that. But you can kind of see where there's pitfalls of these things. I think especially one of the students is probably the best example. I think that you can easily see where ninth graders are not going to be the same attitude as 12th graders. Okay, so here's the reasons you do it. Saves time and money. Okay, here's a little summary. This author does a really good job of summarizing things. If nothing else, to help you with your notes, if I were in your shoes, I'd try to find a good place to make photocopies if you don't have one of your copy machine of your own. If it only costs you 5 or 10 cents to make a copy, I'd make copies of all the blue sheets or all the blue boxes here that are summaries. They're very, very handy, help you study. Okay, so then we have all these other sampling methods. This isn't really math here. I'll let you read that yourself. You can kind of see for yourself. There's all these different techniques of doing it. Okay, I'll let you do that yourself. What is a sampling error? Now, this is a very important concept here. There's always going to be some errors, right? I mean, it's not going to reflect the reality because it's not the population. If you had the resources to do the entire population, you would do so. That would be called a census, as we learned before. You would take a census of the population, but you don't have the infinite resources. So you have to do a sample, okay? There's always going to be some error. That error is called a sampling error. Sampling error is the difference between the results obtained from a sample and the results obtained from the population if you had the resources to do it, okay? All right, so you take a look here, you say, okay, I'm going to select a sample, 56% are female, then you do a census, you go to the admissions office, you do a census, you look at everybody, and it turns out that it isn't 56, it's 54. That difference, that delta, D-E-L-T-A, in math we call a difference a delta. The delta of 2% is because of sampling error, okay? Most of the time we don't know what it is, but sometimes you can estimate it, and we'll talk about that in chapter 7, okay? A non-sampling error is when the data are obtained erroneously or the sample is biased, okay? So maybe you have a defective scale. Maybe your scale just isn't right. Maybe you have a yardstick and the yardstick is shrunk or something, it's just defective, okay? The scale is off by 2 pounds, all right? Maybe you just didn't do a good job writing down the data values, okay? All right, so then we have all these other things. Talk about it in chapter 14, which we are not going to cover, but at least you have an idea of what all this stuff refers to. So here's some review here, some examples. These examples are worth their weight in gold. Do the examples. I'm telling you, do the examples. The ones that require computations, you should be doing with a pencil and paper in your hand. You should write out every single one of those because it will help you understand everything. If you just read it and you say to yourself, oh, yeah, I understand, you're not learning it. You've got to write it out. Now, these kinds of examples here with no computations, I think you can just read it, okay? All right, so I think you can do this on your own here. Okay, so we're almost out of time on this one, so that's the end of section 1-3. Now, I'm going quickly over these because I believe you guys can just read this material on your own and get it. When we get into the other chapters where there's a lot of calculations, the lectures will be a little more detailed because, it takes a lot more effort to go through. It takes you a lot more effort. It's a lot easier to make mistakes when you're doing the calculations. But just reading this material, you're all, I'm sure, good readers, and, you can just read it on your own. Okay, so that's the end of this video. And this video is chapter 1-3. This is recording number 2. I gotta find out how to stop this thing.